titre de cette conférence exprime notre triple conviction que le thème du réchauffement climatique se situe parmi les principaux défis mondiaux des décennies à venir, que la réponse à ce défi nécessite une action combinée des scientifiques, des techniciens et du monde économique afin d'inventer et de mettre en œuvre les changements technologiques indispensables dans les process, dans les produits. But also this technical progress will not be sufficient, and the solution will involve also, of course, mainly governments and civil society, in order that adapted measures can be taken at the different levels and that their effects on our ways of life be accepted, as well in the rich countries as in the less advanced economies.
The main cause of that carbon dioxide buildup over the last 250 years has been emissions from human activities, from fossil fuel burning, and from deforestation. Again, there is no question about that at all. We know what the fossil fuel contribution has been because fossil carbon contains no carbon-14, and you can see the dilution effect in the carbon-14 content in the atmosphere as the human contribution from fossil fuel burning builds up. As you would expect from non-uniform changes in temperature, circulation patterns are changing. This shows the weakening of the East Asia monsoon over the last 30 years. Chinese climate models have led to the conclusion that that phenomenon is a result of greenhouse gas-driven global climate change. Evaporation and precipitation are increasing on a global average, although not everywhere. Some places are getting drier, others are getting wetter. Glaciers are retreating all over the world. This is a before and after, 1941 and 2004, from the same spot in Alaska. Permafrost is thawing, leading to cracked roads, buildings, pipelines, transmission lines, and so on, as the temperature rises above freezing in the soils of the far north. Summer sea ice is disappearing. These are the latest images from the National Oceanographic and Atmospheric Administration in the United States. The pink line shows the long-term recent average sea ice extent. The left panel is 2005, which set a record for reduction in summer sea ice in the Arctic. And as you can see, the right panel, 2007, shattered that record. Again, a pace of disappearance much greater than was expected even a few years ago. Surface melting on Greenland, indicated by the red. 1992, 2002, and 2005. 2002 set a new record. That record was shattered in 2005 for the extent of summer melting. Not surprisingly, in the face of accelerated melting of land ice, sea level rise is accelerating. It's in the last decade twice the rate of average sea level rise during the previous century. And those changes are already causing harm. This is a graphical depiction of the incidence of major floods by decade and by continent from the 50s through the year 2000. As you can see, floods are up dramatically on virtually every continent, the most dramatic rising trend in Asia. Major wildfires up on every continent, decade by decade, around the world. And again, we know why. The conditions that make wildfires more severe are strongly aggravated by the global climatic disruption that we are experiencing. The last time the global average surface temperature was 2 degrees Celsius above the pre-industrial level was 130,000 years ago. At that time, sea level was 4 to 6 meters higher than it is today. The last time it was 3 degrees Celsius, where we will be in the year 2100 under business as usual. 3 degrees Celsius above the pre-industrial level was about 25 million years ago. Sea level at that time was 20 to 30 meters higher. There were crocodiles swimming off Greenland. There were palm trees in Wyoming. It was a very different world. And there's still no official consensus about that. But I believe that it is completely clear that by any reasonable definition of dangerous, the current level of interference and disruption is dangerous. We are already experiencing dangerous anthropogenic interference. The goal of the Framework Convention is already out of reach. The question now is whether we can avoid catastrophic human interference in the climate system. The temperature of the globe on average would rise about another 0.6 of a degree C, even if greenhouse gas concentrations could be instantaneously stabilized, which of course they cannot be. Some realities about the mitigation challenge. First of all, burning coal, oil, and natural gas still supplies 80% of the world's energy and accounts for about 3/4 of the human carbon dioxide emissions. Deforestation and burning in the tropics account for most of the other quarter. 2/3 of those fossil CO2 emissions are coming from the industrialized countries, but the developing countries will dominate after about 2020. Not in per capita terms, of course, but in total terms. Confronting this disruption of global climate, we really have only three options. One is mitigation, measures you take to reduce the pace and the magnitude of changes in global climate that we're causing. The second is adaptation, meaning measures you take to reduce the adverse impacts on well-being that result from those changes in climate. And the third is suffering. It's that simple. The third option is suffering the adverse impacts that are not avoided by either mitigation or adaptation. The chance of a tipping point into catastrophic change grows rapidly for increases in global average surface temperature beyond about 2 degrees C above the pre-industrial level. That's the conclusion of the IPCC in 2007. It's the conclusion of the UN Scientific Expert Group that I mentioned as well. And to have a better than 50% chance of not exceeding that 2 degree C line, CO2 emissions globally must peak no later than 2015 to 2025, and they must fall steadily after that. Some more mitigation realities. The cheapest, fastest, cleanest, surest source of emissions reductions is to increase the efficiency of energy use in buildings, industry, and transport. Many of those approaches are win-win in that their co-benefits in saved energy, increased energy security, reduced conventional pollution, and so on are more than worth their costs. Adequate mitigation that has a chance of keeping us below an increase of 2 degrees C above the pre-industrial level, is going to require putting a significant price on emissions of greenhouse gases, either via an emissions tax or via tradable emissions permits. The cost, ultimately, of doing that, the cost of adequate emission might well reach 1 to 2% of the world's GDP, maybe 1% in 2050, 2% in 2100. It's real money, but as the Stern report has pointed out, and as the IPCC's new mitigation report emphasizes, it is likely to be small compared to the damages that will ensue to the world economy and to other aspects of human well-being if we do not solve this problem.
The IPCC synthesis report, due in November, is expected to say that global emissions of greenhouse gases have already reached 450 parts per million, the threshold level that scientists tell us could cause dangerous climate change. But when you work on this issue day in and day out, you feel you should be numb to the nonstop flow of news stories about what we're doing to our climate and our Earth. It's like the drip, drip, drip from a melting glacier. But you cannot be numb. You cannot get used to it. You cannot somehow shrug it all off as more of the same, because it is getting clearer every day that our climate is changing right now, and it is changing faster than most scientists even imagined. And it is frustrating to see all of this happening and to remember that we've known about this problem for 2 decades, and we've known that human activities are largely to blame, and still we have done very little. We've done very little while the world continues to burn fossil fuels at a record pace. 5.3 billion tons of coal per year, 83 million barrels of oil per day. And we have done very little while greenhouse gas emissions continue to rise in developed and developing countries alike. Climate change, as we all know, is a global problem that demands a global solution. Individually, many countries are taking serious action on this issue, and they deserve credit for what they are doing. For example, Japan's top runner approach, in which the level of energy efficiency achieved by the most efficient product in a specified category today will become the minimum efficiency standard a few years hence, is a great way to spur innovation. And so is the EU emissions trading scheme, which has created the largest emissions trading market in the world. And even in China, we see significant progress.